If you like, so part A and B are to help you do part C, but would you know how to do part C?
Um, not have to get like a common denominator.
That's it. And any idea how to get a common denominator?
Um, if I uh yeah if I times the fraction on the left by 4 and the fraction on the right by 3.
So it's not just 4 and 3. You'd have to multiply it by the entire other fraction. So that's 3x plus 9, and then you would times that. So the common denominator would be 3x plus 9 times 4x plus 12.
Yeah.
And so the other one, if you you have to multiply the bottom by 4x plus 12.
Yeah.
And then to keep it equal, or to keep it the same value, 4x plus 12 on top. What is anything divided by itself?
1.
Yeah, and so you're just multiplying it by 1, so you're not actually changing the value of the fraction. And so what would you multiply the other fraction by?
1.
And so how would you write that one? So the common denominator that we're aiming for, all right, like that, is 3x plus 9 times 4x plus 12. So the first one was just 3x plus 9, so you had to multiply it by 4x plus 12. And so what would you multiply the second fraction by to get the same denominator?
3x plus 9.
Yeah. And so that would get you the common denominator. What would you multiply for the numerator?
3x plus 9 as well.
Yeah. So a lot of students will just put 1 on the top, but the fraction has to be equal to 1. Okay, so what would that give you then?
1.
And so like what would be the next line? So
Uh,
let's say the left fraction, what would that be?
so would it be so on the left it'd be 4x plus 12 over those two like equations, and
Yeah.
then would it be 3x plus 9 over those two equations?
Yeah. And what would be next?
And then after can't we like add the numerators together because we've got the same denominator,
Yeah.
and then that would give us 7x plus 21.
And 7x plus 21. Okay, so that's correct. So we've written it as a single fraction. It now says in its simplest form. Any idea how we can write that in its simplest form?
It could we do x plus 3 over. I'm not sure if that's just in its simplest form or anything, but
No, I think you're on the right track. So you factorize as much as possible.
what so would um uh do I have to leave the x's so that with on their own or
Um, so is there any way you can factorize the top?
yeah, so x plus 3
And what's the common factor then?
7
Yeah. How about what's on the bottom?
uh um but,
So 3x plus 9. Can you factorize that?
can I factorize that to x plus 3
Yeah. And what's the common factor?
uh 3
Mm-hmm. And so two brackets are times each other. And so that's times, what's the other one factorized?
x plus 3
And outside the bracket?
4
Okay, so what can we simplify there?
We could take out. We could cancel out the x plus 3 on the top and 1x plus 3 on the bottom.
Yeah. And so, final answer?
7 over 12. 12x plus 36.
And I think we could leave it as 12x plus 3.
Oh, okay.
Because it's good to leave it factorized, because you might be able to find something later on that it can simplify with, like if you had to later on add it in part B or something. Any questions there?
No.
So the big idea is the easiest way to get a common denominator. It won't be the lowest common denominator, but just any common denominator will be multiply the denominators together.
Yeah.
And so if you multiply the bottom so basically multiply the bottom of each by the other one.
Yeah.
And so you don't change the value, you multiply the top by the same. And so you're just multiplying it by that. This one. So now what we could have done was we could have factorized these at the start and then did it. So let's factorize it from the start this time. So x squared minus 16, can you factorize that?
X brackets x plus 8 and x minus 8. Is it?
That would give you 64.
4, sorry. X plus 4 and x minus 4, I think.
Yeah. And so common denominator.
Yeah. Well, x plus 4 and x plus 4 are both common denominators.
So yes, so they have x plus 4 in common. So what would we have to do to make them have the same denominator?
Get the x minus 4 out of the way.
And so what would we do? I think what would be, instead of trying to get rid of x minus 4, I would just like put an x minus 4 on the other fraction as well.
Oh, okay, yeah.
And so how would you do that?
All right, when you make the top the numerator x minus 4 as well, if you wanted to put x minus 4 at the bottom.
Okay, and so what's on the bottom now?
X plus 4 and x minus 4.
Yeah. And what you notice is that that's the denominator for the other one already. So actually we only needed to change one of the fractions this time. Okay, what do you get?
Is it x minus 3?
Yeah.
And then over x plus 4 and x minus 4.
Yeah. And you don't have x minus 3 on both the top and bottom or anything. And so that's it. And so it's much simpler if you factorize at the beginning, because then you only multiply by what you need. Any questions about that?
No.
Okay. Let's see. Let's just do question C.
Okay. Right. So okay, so I need to factorize it.
Mm-hmm.
So for the left fraction to sorry, I think I just need a quick reminder. Which was the product and which was like the sum in the equation?
C, the one without x, is the product.
Right.
Because that's like first outside, inside, last. So that's when the two last multiply by each other. And then B, the one with the x, is the product. That's the outside plus inside.
Okay, thank you. So would so on the left would it be x plus 2 and x plus 4?
Yeah.
And that's over 1. And then on the right it would be Would it be on the right, x minus 4 and x plus 7? Oh, sorry, x plus 4, x minus 7, sorry.
Yeah. 7. Okay, so what could you do next?
So they both got x plus 4, x plus 4s in common. So would I like times x minus 7 times 1 and times x plus 2 times 3?
Yes. And so what would you get?
Okay, so on the left it would be x minus 7 over x plus 4.
Anything else? So you multiplied the top by x minus 7?
Yeah.
And so what else? What do you have to multiply the bottom by?
Would I have to times x plus 4 times x minus 7 as well?
Yeah, basically. And so if you multiply the bottom by x, okay, so what would you multiply the second fraction by?
X plus 2.
Yeah, x plus 2. And on the top?
3 and x plus 2.
And so what is now the denominator?
X plus 2.
Go on.
And then
So the denominator was x plus 2, x plus 4.
yeah.
And then you multiplied it by x minus 7. And so it's, or x minus 7. And so it's now x minus 7 on the bottom. And so what would be the other denominator be?
Oh, it'd be the same, wouldn't it? It'd be
Exactly, yeah.
same denominator. Yeah.
So you could write it slightly differently, but it means the same thing.
Yeah.
And that's why you're multiplying the top by that. So the easiest way, instead of trying to take away the stuff, is to just multiply it in. And so this one you have to multiply the bottom by x minus 7, so you have all 3 for that one. And this one you have to multiply the bottom by x plus 2, so you have all 3 for that. So that's the easiest way you get a common denominator. And then you just have to multiply the top by the same thing, so to keep the fraction, so you don't change the fraction, the value of it.
Okay.
And so what's on, so this one you said 3 times x plus 2. Okay. And so what is next?
Do I need to don't I need to like cancel out the numerator and denominator, or
No, you just, that would bring you back to where the question is.
sorry, so I need to add the numerators together.
Yeah.
And so that would be and so that would be 4x minus 1, I think.
Yeah. And that's over?
Over x plus 4, x minus 7, and x plus 2.
That's it. X plus 2. So you have to get the denominators to be the same. So you multiply by whatever you need to, and then you multiply the top by what you just multiplied the bottom by. So you keep the value of the fraction the same.
Yeah.
Because you're just multiplying it by 1. Because x plus 2 over x plus 2 is 1. Any questions about anything there?
No.
Okay. And so this fraction here, so they said write it as a single fraction in its simplest form, and that's what you did. It was 2 different fractions being added, and now it's one single fraction with one common denominator, and that's it. Yeah. This one. All right, we'll do it.
Okay, so
Nah, it's too. This one's just too. It's a bit of an academic one. I think you'll be fine. Oh, this one's slightly different. Okay, we'll try it. You can ignore this thing on the right. Just do these two on the left.
okay. To expand, so I need to expand the brackets, and so that would be as the denominator x plus 3 and x plus 2,
Okay.
and for the fraction on the right, it would be 5 and x5, and then bracket x plus 2.
Yeah.
And then if I like so if I times if I times 5 by the fraction on the left, and then times x plus 3 on the fraction to the right.
So let's say, what would your common denominator be?
X plus 2.
So it could be x plus 2, but then you would have to divide by x plus 3 and divide by 5. It's much easier to multiply something extra in than to divide.
Alright, so the denominators for both fractions end up being x plus 2, 5 and x plus 3.
Yeah. And so you have to make both of them have that denominator.
Yeah, so for the fraction on the left, if I times it by 5, I'd get 5 over x plus 3, x plus 2 and 5.
Yeah, and I'll just write the 5 at the start. That's how they usually write it.
Alright.
Yeah.
And for the fraction on the right, it would be so x plus 3 over x plus 3 over 5, and then brackets x plus 2 and x plus 3.
Yeah. Go on.
And then after I need to add the two fractions together, and that'd be 5x plus 3 plus
5.
8.
It's 5 plus x plus 3.
Oh, right, sorry. So x plus 8, I think.
Yeah.
And over the denominator.
That's it. Can that be simplified?
Would I have to expand the brackets or?
No. You do the opposite. The reason why you factorize is because so then you can cancel it. No, you can't simplify it. If you had an x plus 3 on top, you could cancel it down. If you had an x plus 2 on top, you could cancel down. Or if you had a 5 on top, you could cancel down. Or I suppose if you had a bracket with x plus 8 on the bottom, you could cancel down. But you don't. They've nothing in common, so that's it.
Okay.
Yeah, so this one, so x plus 3, x plus 2, x plus 2, 5. And so in total, you've got x plus 3, x plus 2, and 5. And so those are the three things that are going to be in the denominator. And so you'd have to multiply this one by 5 and this one by an x plus 3 to get them to have all three each. Any questions about that?
No.
Okay. Okay, let's try this one. How do we do A?
So simplify. Okay, so can I start off with? Can I? Would I expand the brackets on the left?
You don't have to. The easiest way to multiply fractions is for them to both be fractions. Anything divided by 1 is itself. And so you can just put that one over 1. And now it's just multiplying fractions.
Oh, I get it. Right. And then would it just end up being the numerator being 2x plus 6?
Don't expand it.
Oh, sorry. 2x and then x plus 3 and then 2 and x minus and x minus 2, sorry.
Yeah.
And then over x minus 2.
Okay. And it says simplify.
Okay, so if would it be 2 and then x plus 3 over 1?
Yeah. And what is that divided by 1?
2x plus 3.
Yeah, equals 2x plus 3. And that's why we didn't expand the brackets, because if you keep them factorized, then you can cancel them down.
Yeah.
If you expanded them, you just have to factorize them again to see if they do cancel down. Okay, let's try B.
Okay. So if we put like a 1 as the denominator for the fraction, the equation, and then you just do 4, and then in the brackets x plus 6, and then x plus 4, and over x plus 6, and then cancel out the x plus 6's, and then you're just left with 4x 4, and then brackets x plus 4 as the answer.
That's it. Any questions there?
If you don't get a numerator, is the answer just the denominator? Oh, sorry, other way around. If you don't get the denominator, is the answer the numerator?
Well, I mean, the answer is really like 4x plus 4 over 1. It's just that we can make it even simpler by dividing that by 1.
Right.
So, is that what you mean?
Yeah.
Okay.
All right. Thank you.
You're gonna be fine for those. Solve by factorizing. You're gonna be fine. Quadratic formula. I think you'll be fine. So I just want to focus on the actual fractions. Let's see. Okay, how would we do A?
Okay, so would we take answer? So, was the answer would A be 5 over 4 equals to x, or?
If you rearranged it, yeah. So it starts by being 5 over x equals 4. If you rearrange that, yeah, 5 over 4 equals x. And that's your answer. X is 5 over 4. How about B?
So, yeah. So. Would B be 4 over 7 plus 1 equals to x?
4 over 7 plus 1. What is 7 plus 1?
8.
And so x is 4 over 8?
Oh, right, so x is a half.
So x is a half. That's it. Okay, you're good for those. Yeah. 5 over 4. Okay. Okay, let's try A for this one.
Okay. Would we first get the denominators the same and then times x by the fraction on the right and times 5 by the fraction on the left?
Well, if you're adding or subtracting, you have to get a common denominator. So these are just on different sides, so you don't need to. Basically, all you have to do is aim towards getting x equals and then a number. So get all the x's on one side, all the numbers on the other side.
Yeah.
Any idea how you do that?
Yeah. So, oh yeah. So it's one of the first things you do. You take the 5 on the fraction on the right and times it by the fraction on the left.
Yeah. So times both sides by 5. Okay.
Yeah.
What do you get?
If it's 4 over x equals to 5.
So if you
5 times 4 over x equals to 3x minus 7.
yeah. And what is 5 times 4?
20.
So 20 over x equals 3x minus 7. What's next?
Equals 3x minus 7. And then after you would take the minus 7 and put it to the other side. So it's 20 over x plus 7 equals to 3x.
Well, before you do that, I would get rid of the next fraction as well, so there's no fractions anymore.
Right. So would we take the x on the left and then just times it by the fraction on the right? Equation on the right.
Yeah, so you're timesing both sides by x.
And then that's 20 equals to x and then brackets 3x minus 7.
And what do you get when you expand that bracket?
3x squared minus 7x.
Okay. And what's next?
You would you take the square root and then put it onto the the square and put it to the other side, so it's square root 20 equals 3x minus 7x.
How do you solve a quadratic equation?
I'm not sure.
Let me just get back for a sec. How would you solve part A for this one?
So you'd factorize it.
Yeah.
It'd be x plus 2 and then x plus 4, and then you do x plus 2 equals to 0, and then it'd be and x plus 4 equals to 0, and then you do x is equals to minus 2 or x equals to minus 4.
That's it. How would you do this one?
Would you put
So do you know the quadratic formula?
not with like numbers and like the x squared bit.
Okay, so they give you this formula.
Okay.
And for this quadratic, and that's when you have ax squared plus bx plus c equals 0. So for this one, what is a?
A is a 3.
B?
8
and c.
minus 17.
Yeah, and so just sub them in.
Okay.
That's what you get.
Minus 8,
Mm-hmm.
and then
And I'll just write plus or minus for now.
yeah, and then square root 8 squared minus 4 times 3 times minus 17.
Yeah.
And then that's like a fraction over 2 times 3.
That's it. So then 2 decimal places, so it's a calculator question. Any idea how you put the plus or minus thing into your calculator?
Don't you do it with minus 8 plus the thingy first off, plus the square root first time round, and then the next time you do like minus 8 minus the square root the next round, and then you put like x equals to this or that.
That's it. And so you get the 2 answers. So you just put them in separately. So how would we solve this one that we got to here? 20 equals 3x squared minus 7x.
We would. Would we use the same equation?
Yeah. And the trick is it has to be equal to 0. So how would you make it equal to 0?
You take 20 to the other side, so it's 3x squared minus 7x minus 20.
And so what is A, what is B, what is C?
A is 3.
Yeah, go on.
B is minus 7. And C is minus 20.
Yeah, and then you just put those into the formula.
Yeah.
Any questions about that?
No.
Okay. Same thing. Okay, let's try this one.
Okay. So would we times 2x minus 1 by the fraction on the right and x plus 2 by the fraction on the left?
Yeah.
And then so the fraction on the left would come out as 3, and then x plus 2 on top, and then as the numerator, and then on the bottom on denominator it'd be 2x minus 1 and x plus 2, and then with the fraction on the right it would be plus 4 and 2x minus 1 over 2x minus 1 and x plus 2.
Mm-hmm.
And then you would add those together, and so it would come out as and then it'll come out as 11x plus 2 over.
Hold on. What's 3 times 2?
6.
Oh yeah. Sorry. Plus 2. Yeah, go on. Over.
Over 2x minus 1 and x plus 2. I think that's the final answer.
Well, in this case, it's an equation, so you're told that's equal to 2. So you have to now solve
it. Do I need to solve?
So you would do what we did here, same idea. You have to then solve it. So how would we go about solving this?
We have to find what x is.
Yeah. How would you do that?
So you would If we just took both the brackets on the denominator, and then just took them to the other side, so it's like 2, and then 2x. So it's 11x plus 2 equals to 2, and then 2x minus 1x plus 2.
Well done. And what would you do after that?
And then after x plus 2, and then after you would you would take. Would you take? Oh, sorry.
So, like the previous one, it turned out to be a quadratic. If we expanded these double brackets, would we get a quadratic?
Yes.
And so you would have to then solve this like the last one, where we fully expanded everything, fully simplified everything, and then made it 0 equals, and got A, B, and C. So how would you go about that?
So would we first of all have to put 11x? Would we have to take the 2 to the other side?
Let's expand the brackets first. That'll be a bit easier.
So do I have to expand the 2 with the 2 brackets, or?
Yeah, it might be easier to just expand the 2 brackets first.
Okay.
And then just double it.
Okay, so the answer would be 2 x squared minus x minus 2 plus 4x, and then simplified that would be 2x squared plus 3x minus 2. And then do we just times that whole equation by 2?
Yeah.
And then it would be 4x squared plus 6x minus 4.
And now I'd bring over the the 11x and the 2.
If we took, if we took the minus 2 to the other side, it would be plus 2. So it would be
it's already a plus 2.
Oh right, sorry. So it would be so 4x squared minus 17x minus 6.
Plus 6 minus 11.
Minus 5x.
Yeah.
Minus 6.
That's it. And what's now on the left side?
0.
And how would we solve that?
So 4 is A, B is minus 5, and C is minus 6.
That's it. And you just sub them into the formula and put it in your calculator.
Yeah.
Any questions there?
No.
Okay, so if I still haven't figured out how to put my calculator onto this laptop, but yeah, you would just put it into your calculator. Let's see. That's the same. Let me just see what we just did. So we did one that was 2 linears on the bottom. So we did harder ones than that. Let me just check. So we did adding 2 linears. So that's that. That's that. Okay, how would we do this?
The exact solutions. Does that just mean like solve what x is?
Yeah, but let me just come back to that because that's a bit too straightforward. And then this crazy one, let me see this. I showed it that's just to show that question. And then this one Do this.
Okay. So. I'm just writing it down.
Okay.
So would I first of all take the 5, the denominator of 5, and take it to the other side, so it's like times 3x plus 11,
Mm-hmm.
and then that would be 15 minus x equals to 5, and then brackets 3x plus 11.
Okay.
And I should probably expand the bracket, shouldn't I?
Yeah.
And then that would be 15 minus x equals to 15x plus 55.
Mm-hmm.
And then if I take the minus x, if I swap the minus x with the plus 55, it'd be 15 minus 55 equals to 15x plus x. So it'd be 15 minus 55. So minus 40 equals to 16x, and then minus 40 divided by 16 equals to x.
And can you simplify that fraction?
I think we're going to like a decimal, wouldn't it?
Yeah.
So minus 1 divided. Yeah, that would be minus 2.5.
Yeah. So x is minus 2.5. Any questions there? X.
So if we times x plus, yeah, so if we on there, if I times x plus 1 and x plus 2 times 2, so it's like, so they're both, so it's just 5 plus 4 on the left. So it's just, 9 equals to 2 times x plus 2 and x plus 1.
That wouldn't be correct, because you'd have to multiply everything by x, all three of them by x plus 2, all three of them by x plus 1. I think you're probably better off just adding the two fractions.
Okay. Yeah, so if I did x plus 1 times the fraction on the left and x plus 2 times the fraction on the right.
Okay.
And then it would be 5 and then brackets x plus 1 over x plus 2 and x plus 1.
Mm-hmm.
And then plus 4 and then x plus 2 over x plus 1 and x plus 2.
Mm-hmm.
And then if I expanded the numerators, it would be 5x plus 1 plus 4x plus 2, so it'd be
Hold on, not plus 2.
plus 8.
And actually the other one isn't plus 1 either.
Oh, it's 5, yeah.
Yeah.
And then, so it would be 9x plus 13
Mm-hmm.
over x plus 1 and x plus 2.
Yeah.
Equals to 2.
Yeah.
And then after, would I then take the denominator and times it by the 2?
So what would you get?
So 9x plus 13 equals to 2 times x plus 1 and x plus 2.
Say it again, sorry.
Would it be so 9x plus 13 equals to 2, and then x plus 1 and x plus 2?
Yeah.
And then uh would I expand the I'd expand the brackets on the right, wouldn't I?
Mm-hmm.
So it would be x squared plus x plus 2 plus 2x, and that would end up being x squared plus 3x plus 2, and then you times that by 2, and then it's 2x squared plus 6x plus 4. And then if I take the equation from the left, and then that would be, say, 2x squared minus 3x minus 9. And that's the 0 equals 2. And then you'd do like the little equation with b and a. Well, so 2 is a,
Mm-hmm.
and then minus 3 is b, and minus 9 is c.
That's it. I just want to see, will this one actually factorize? So if we put this into two brackets, one is going to have 2x and the other will have 1x. Will that be possible? So the minus 9. So minus 9 could be written as minus 3 times plus 3. And so I think if that was minus 3 and that was plus 3, that you get 2x squared, you get minus 6x plus 3x, that's minus 3x, and then minus 9. Yeah. And so how would you solve that?
Am I solving the equation at the bottom?
Yeah.
Okay. So that would be 2x squared.
No. They're both equal to 0.
Sorry. Yeah. Say 2x plus 3 equals to 0.
Yeah.
And so 2x. So x is equals to minus 1.5.
Yeah.
Or so x minus 3 equals to 0, or x is equals to 3.
That's it. And so you get two answers, x equals minus 1.5 or x equals 3. And if you had done it using the ABC method, you'd get the same answers.
Yeah.
Any questions about that?
No.
Okay, so yeah, basically if you've got two, so I mean it's kind of, so for the hardest possible type, if you've got two fractions being added, you get a common denominator by multiplying by the other denominator, top and bottom, and to keep it, same value. Bring them together, simplify, and then solve by making it equal to 0 and doing quadratic. So that's if you're adding or subtracting in an equation, which is the hardest type. And then the exam questions weren't quite that challenging, but